Hello, my name is Agatha, and today I'm going to be going through the solutions to the Mission Math Winter Competition from 2026. So this is our exam for 6th through 8th graders, which is our most challenging exam. So if you participated and took this exam in our most recent competition, then this is a great opportunity to look through the questions you didn't understand or that you got wrong and better understand those and understand those solutions. Or if you are prepping for an upcoming Mission Math competition, this is also a great opportunity to get to know our exam format and also just learn some strategies that will probably come up in the test you take as well. Our tests are structured with 30 questions each, and they range roughly from least difficult to most difficult. So we're just going to get started with question 1. Adrian is reading a book that has 120 pages. He reads at a rate of 5 pages per minute. How many minutes will it take him to finish the book? So if we know 5 pages per minute and he reads 120 pages and we're trying to find how many minutes it takes him, all we have to do is 120 divided by 5 and then 24 minutes. Pretty straightforward. Okay, question 2. What is 0.67 expressed as a common fraction? So this is one that could totally come up on another test and has a very easy trick to it. In this situation, the answer is 67 over 99 because whatever number you have over 99 is going to be repeating. So this line right here means repeating, which basically means they're asking what's the fraction equivalent of this, and then that's just going to keep going back and forth. And so when you have a value like this with x over 99, that is always going to be, assuming that x is less than 99 in this scenario, it's always going to be that x value repeated. And then if this is a value less than 10, for example, if it's 1 over 99, then that's going to be 0.010101 repeating. So then, obviously, in this scenario, it could just be 67 over 99, and that's going to get you to 0.6767 repeating. Okay, number 3, what is 130% of 40% of 500? In this situation, you can use the multiplicative property, which is just basically saying that you can multiply these together. So percents can be converted into decimals, basically just by going 2 decimal places to the left. So there's our decimal there, move it 1, 2, and that becomes 1.3. And then we can do that with 4 as well, so just move 2 decimal places over, and that becomes 0.4. So that's 1.3 times 0.4 times 500. I would probably do this first because this is pretty easily 200. And then I would do the longer multiplication here. We need the decimal point there, carry it down, and you'll get 260. The sum of 3 consecutive integers is 231. What is the value of the largest number? Basically, if you have 3 consecutive integers, that means they come one after another. So like 1, 2, 3 could be an example of 3 consecutive integers. So how I would solve this one is by using a value of x, where x is the smallest value. Make sure to make a note of that we are solving for the largest number, not the smallest, but I think the smallest is the easiest to start with here. So then I would set it up as x is our smallest value, and since we're summing them, we'll do plus, and then x plus 1, because the next integer is just going to be plus 1. So back to that example of 1, 2, 3. If we say x is 1, then x plus 1 is 2. So that would continue us on. And then x plus 2 would be 3. So that's the general structure of what consecutive would mean in this scenario. So we can just do that exact same thing over here to set up a general equation, and that's going to add to 231. So now we can simplify this equation because there's 3 x's, and since it's all just addition, we can add that up. So 3x plus 3 equals 231, And then we're going to subtract 3 on both sides, and that's 3x equals 228. And then from there, just a little bit of division, and that'll get us to 76. We have to be reminded that x is our smallest value. So we know that x equals 76, but we're getting asked what the largest number is. And if you look back over here, our largest number is going to be the x plus 2 value. So we're going to plug that in and solve for 76 plus 2, which equals 78. And that will be our final answer. Number 5. Ananya is playing with blocks in the shape of cubes. She builds it so the length is 30 blocks, the width is 30 blocks, and the volume of the figure is 9,000 blocks. What is the height of this figure? So this one's pretty straightforward, that you just need an understanding of how to calculate volume. So that's volume equals length times width times height is the general volume formula. So in this scenario, we can kind of plug everything in. So we know that the final volume is going to be 9,000. We know that the length is 30 blocks. We know the width is 30 blocks. And then we are trying to solve for the height. And when we set up equations like this and there's just one unknown variable, then that means we can pretty easily solve for it. So we have 9,000 is equal to just 900 times h. So with a little bit of easy division there, you can see that h equals 10, which is our final answer. Also, a good thing to know about our test is you do not need to include units, which is kind of nice, so you can just focus purely on the number. A shop sells 3 different flavors of ice cream: vanilla, chocolate, and strawberry. You can choose 2 not necessarily distinct scoops for your cone. How many unique 2-scoop cones can you make? The terminology of not necessarily distinct might sound a little bit confusing, but that just basically means that the 2 scoops of ice cream can be the same or they can be different. Okay, so we have 3 flavors: vanilla, chocolate, and strawberry. And with this condition of not necessarily distinct, that means you could have vanilla vanilla, or you could have vanilla chocolate, etc. So you could write out all the possible 2-scoop cones you can make, which is pretty achievable for this problem. So there's definitely a brute force method. Usually what I do with a combinatorics question like this is I look at this question here of how many 2-scoop cones can you make. So I'll make 2 spaces. Above each line, you're going to write the number of options you have for that scoop. So for your first scoop of ice cream, you have 3 different flavors to choose from. And then for your second scoop of ice cream, you also have 3 different flavors, right? Because it can be the same flavor together. And then finally, just multiply those, and that will get you 9, which is the total possible options. Alright, number 7. A cylinder and a cone have the same volume and radius. What is the ratio of the height of the cone to the cylinder? So first we'll do volume of a cylinder, which is pi r squared height. But this basically comes from the idea that it's base times height, and since the base is a circle, the area of a circle is pi r squared. So that's that base down there, and then multiplied by height. So for shapes like this that have a standard, I guess, like width the whole time, usually that base times height equation will work, and it applies here. Unlike that, we have the volume of a cone, which unfortunately you just kind of have to memorize. But it's very similar to the cylinder equation, just with that 1/3 out front. Okay, so now knowing that, and being reminded they have the same volume and radius, we can actually set these equations equal to each other. Okay, so this is what our equation looks like set up, but one important thing to add before we start solving is to remember that we're comparing the height of the cone to the height of the cylinder. So that implies that heights are not equal. So we must label our heights: height cylinder and height cone. So since we know that they have the same radius, we can cancel r squared and divide that from both sides. We can also divide out pi from both sides, which really simplifies our equation. So now it's just the height of the cylinder is equal to 1/3 of the height of the cone. So now let's set up this ratio. Basically, they're asking what is the height of the cone over the height of the cylinder, right? And given this equation, that's something we can pretty easily solve for, where we can multiply the 3 over and divide by height of the cylinder and get 3 equals h cone over h cylinder. So then our ratio is equal to 3. All right. Question 8. The sum of Anita's and her brother's ages are 24 and the product is 140. How much older is Anita than her brother? This one just requires setting up some equations. So A will stand for Anita and B will be her brother's ages. And those add up to 24 as we pull out the word sum. And the word product means multiplication, so then we know A times B equals 140. I think the easiest is just to kind of reason it out from these two equations. So you can go through a few different options, but I think the easiest one that did come to mind for me was 140 being 10 times 14, which, if you notice, that just so happens to also add 10 plus 14 equals 24. So that one's pretty easy to see if you just kind of logic it out. There is more algebraic ways you could do that, but I think the logic works perfectly fine for this. And then the question is, how much older is Anita than her brother? Because in both of these, the only thing to tell us which one is actually Anita is by this end of the question, which suggests that she is older than him. So we can assume that Anita is 14. So then 14 minus 10 equals 4. Question 9. Ryan flips a coin 8 times. What is the probability he gets at least 2 heads? Express your answer as a common fraction. Okay, so this is a problem working with probabilities. And one thing to know about probabilities, if you haven't worked with them a ton before, is that all of your probabilities, which in this case there's going to be 2 total probabilities we're thinking about, are going to add up to 100%, right? Because even, let's say you just flip one coin, the probability of getting heads and the probability of getting tails is both 50% or 0.5. And so when you add those up, those will always equal up to 100% or to 1. So that's something good to keep in mind. Because with a problem like this, where it's asking, what's the probability he gets at least 2 heads? That's saying, in terms of casework, which means reasoning out the probability of getting 2 heads when he flips a coin 8 times, but also figuring out the probability of getting 3 heads or 4 or 5 or 6 or 7 or 8, which means that there's 7 different cases that you have to go through, as opposed to if you do the opposite, which is a little less casework, which is the method I'm going to suggest. And the less casework means that we just do 2 cases instead. So case 1 is that we get no heads. In order to get no heads, that would mean that you would have to get tails every single time, which, just working with basic probability rules, that would be 1/2 times 1/2, etc., until 1/2 2 to the 8th. So that is the probability that after flipping a coin 8 times, you get no heads. Now, case 2 would be where you get 1. In this case, we're going to have to apply something called the n choose k formula, which you may or may not have heard of before. That's when we will be doing 8 choose 1. So the n choose k formula basically means that for a probability / combinatorics question, you have n options. How many ways are there to pick k things from those options? So for example, let's say you have 8 different colored pieces of candy, right? How many ways can you pick one piece of candy from this group? So that's a pretty easy problem, right? 8 choose 1 would just be 8, because all the possible ways that you could pick just one candy is 8, because you could pick each of the candies once. Of course, it gets a little bit more complicated if it's saying you have 8 candies, but how many ways can you choose 2 candies and have a group of 2 picked out of them? If you are interested in learning more about that, there's lots of great videos, and honestly, it will come up in competition math, so it's a good thing to know. Here is that formula. But for this question, we actually don't really need to get into that, because 8 choose 1 is just 8. The reason that we're doing 8 choose 1 is basically out of all these 8 coin flips, right, we're choosing one that is heads. So we're saying how many different ways out of his total coin flips is that possible. So that means the probability is going to be 8 over 2 to the 8th. And for this question, you kind of just need to know what 2 to the 8th is. Of course, this one you could also just multiply out in the moment, and that's totally fine as well. So basically over here you have 1 over 256, and then over here you have 8 over 256, which totals to 9 over 256. But we're not quite done yet, because if you remember, we chose to do these two alternate cases, but the real question is what's the probability he gets at least 2 heads? So it comes back to this idea that our probabilities have to add up to 1. So we figured out the probability of him getting less than 2 heads, right? Which we now know P1 to be 9 over 256. And then our other probability, being the probability we're actually looking for, the probability he gets 2 heads or more, is going to be P2, and those add up to 1 in total. So now that we have this equation set up, that's pretty easy because now we're just doing 1 minus 9 over 256, which is the same as 256 over 256 minus 9 over 256. So then that will be 247 over 256, which is a pretty big fraction, but looking at that, I'm pretty sure that cannot be reduced anymore. And this request of express your answer as a common fraction, you've probably seen it a bunch of times, but basically that just means express your answer as a reduced fraction in this format. We never want any of those weird mixed number fractions like 1 and 1/2. You should never be answering like that. Instead, you should be answering in the 3/2 variety. That's a common fraction. Number 10. What is the area of an equilateral triangle with sides 6? Express your answer in simplest form. Equilateral triangle, we know the equal means that all the sides are of equal length. And so with side length 6 means that that was a bit of an uneven equilateral, but pretend it's even. So that means all sides are 6. And if you'll remember, the area of a triangle is 1/2 base times height. We already know the base, right? Because we know that to be 6, but we don't yet know this value of the height. But what we do know that's nice about an equilateral triangle, we know that this right here, this part, which is half of an equilateral triangle, is a right triangle. We know this because this height from the base to the top, it doesn't really look it in my picture, but that is perpendicular to the base, which means it's going to form a 90-degree angle, which then tells us that that is a right triangle. And if you know anything about right triangles, we know that that is when we can use Pythagorean theorem. So in our triangle, let's go ahead and assign A, B, and C. Our hypotenuse is what we label as C. So if you look at this, we know 2 of these already. So A down here, since this is half of the triangle, and this whole side is 6, it's actually, A is going to be half of that, so A equals 3. And then B is the value we don't know yet, because that's what we're solving for in order to answer our final question of what the area is. And then finally, we already know what C is, because that's going to be 6 squared. Okay, so with this much information, we can actually just solve it from here. So 6 squared, of course, is 36. 3 squared is 9. So B squared is going to be 36 minus 9, which is 27. So with just a quick square root, B equals root 27. If we look back on our graph right here, B is equal to height. So in our formula, we now have all the pieces to be able to solve for area. So area equals 1/2 times base. So 1/2 times base is going to be 3, and then multiply that by our height right there, which will get us to 3 root 27. And the answer is 9 root 3, because we just multiply these 3's, and then there's a 3 remaining as a factor in there. Now question 11. F of x equals x to the third minus 3, and g of x equals 2x minus 1. What is the value of f of g of 3? So this one's pretty easy to break down if you have ever worked with functions before. If you haven't, they're pretty easy to learn. It's just a matter of plugging numbers in. So first, we're going to begin with the inner function, which is g of 3. So g of 3 basically means, when we're looking at this equation right here, do you notice how 3 is replacing x in that function formula? That's because that's saying that x equals 3. And given that x equals 3, we can now solve for the value right there. Because g of 3 then means that that's 2. We sub in 3 for x, minus 1, which is 6 minus 1, which is equal to 5. So that is the value of g of 3. So now let's look back at this right here, where now the function of f is being applied to g of 3. And we now know what g of 3 is, being 5. So now we're going to solve for f of 5. So we're going to come back down here. And f of 5, it's that same thing where we're substituting x. So x equals 5. So we're going to put 5 in for x to the third minus 3. 5 to the third is 125. Just a good cube to memorize. And that's 122. And that is our final answer. Question 12. This one's a little bit tricky. Express 1101001101 base 2 in base 4. The usual numbers that we use, like, for example, our answer from last time, 122, is in base 10. And what that means is that if we break down 122, that means we have 1 100, 2 10s, and 2 1s. But now we can start to think about numbers in other bases. So this place most to the right is going to represent 2 to the 0th. So each of these places are going to represent another power of 2. Just like how in the base 10 system, we're thinking about it in ones, tens, hundreds, thousands, and etc., which are all exponents of 10. So this is what base 2 looks like, and we're trying to convert it into base 4. The nice thing about converting from 2 to 4 is that we can actually work in pairs. As you can see by these values up here, we have repeating values, which means, very nicely, that we can group these together as I've done with the parentheses. First, let's look at 4 to the 0. So 4 to the 0 is where we put the numbers that are less than 4. So they're not great enough to make any values to the left. So if we look back at base 2, the only values that are less than 4 is within this first group of parentheses, and we just have a value of 1 there. So we're going to transfer that over and put a 1 right there. Okay, next we're going to go 4 to the first. This is the place for all the values that are less than 16, but at least 4. And that's exactly where this group is going to fall into. So here we have a 4 and we have an 8. We can add those together. That's 12. And then it's moving it into this place. That's 4. So this is actually going to be a 3. 12 divided by 4 is 3. So I hope this makes sense. This is definitely a confusing concept and not easy to wrap your head around because we've been learning base 10 our literal entire lives. Okay, so this place value of 4 to the second are for values that are at least 16 but less than 64. So again, that falls in this set of parentheses. And here we have a 0 and a 0, so that's actually just going to be a 0 there. Then 4 to the third, those are for values that are at least 64 but less than 256, which is this pairing, and that's just going to be a 1, right? Because we just have a 1 right there. 164. And then finally is a 4 to the fourth. So these are for the values that are at least 256 but less than 4 to the fifth. And so that's going to be this last parenthesis group right here. And we're counting the number of 256s that are in this group, which is going to be 3 again, because it's 512 plus 256 divided by 256, which is 3. So then your final answer is going to be 31031. I know that was a lot of information if that was a new idea to you, so please do research more if you're interested, but those are just the absolute basics of how to apply it to that question. Question 13. There's a bag with 9 yellow marbles, 11 green marbles, and 13 blue marbles. What is the minimum number of marbles you can pick to guarantee you have at least 10 of one color of marbles? So these questions are tricky because they're saying, what is the least number you can pick, but you have to guarantee you have at least 10. But in order to guarantee that you're going to pull them, you actually have to make the assumption that you're as unlucky as possible. So to start out unlucky, first, you're going to have to pull these 9 yellow marbles. Because if your goal is to get 10 of one color, that means it is impossible to get 10 yellow marbles. That means first you're going to pick the 9 yellow, and that's your first step. We have 11 green marbles and 13 blue marbles. So we can't apply the same logic because you could have a solid 10 of either of them. But instead, we have to stay in that mindset of what's the least lucky that you could get, and that would be getting back and forth. So getting 1 green and then 1 blue, and then 1 green and then 1 blue. So this is the slowest possible process to getting all of these numbers. And actually in this problem, either way works. It doesn't actually matter whether it's the green or the blue. It's just the matter of it's the two of them going back and forth. So now assuming that this is what's going to continue, we know that we're going to get to 10 green first because that's the first in this order. So we have 9 yellow plus 10 green, and then how many blue along the way? So between each green, we're going to have 1 blue in the middle. But it's good to remember that when we stop pulling is when we actually get to our last green, which means we're not going to complete this pattern of 2. So we're actually just going to pull 9 blue in total. So then adding that up, that's 9 plus 10 plus 9, which equals 28 total marbles, which is our answer. Square A has a side length of SA and an area of AA. Square B has a side length of SB and an area of AB. Okay, given that AA over AB equals 25, we're solving for SA over SB. So if we're reminded the area of a square is just the side length squared because your side length is going to be the same, AA is just going to be SA squared, and over here AB is going to be SB squared. So now that we have those values, we can actually put them into this equation that we were already given. So then AA over AB is actually SA over SB, each of those squared, right? We can then just square root because we're trying to get this final answer of SA over SB. So we can square root the whole fraction and also square root this, which is a nice square. Then that's going to get us to SA over SB, which equals square root of 25, which is 5. Okay, 15. What is the expected value of a single roll of a 20-sided dice where even numbers show up twice as often as odd numbers? Express your answer as a common fraction. The basic formula for an expected value is basically adding up the probability of getting a certain value times that value itself. And also the other thing that you have to watch out for is that even numbers show up twice as often as odd numbers. And it is still a 20-sided die, which means it has the numbers 1 through 20 on it. But it's already told to us that it is an unfair dice, which means that unlike a fair dice where all sides would have an equal 1 over 20 probability of getting rolled, now your odd numbers are going to actually have a 1 in 30 chance, while your even numbers have a 2 in 30 chance. The reason that it adds up to 30 is because, kind of like what we talked about earlier, is your total probability has to add up to 1. So in order for it to show up twice as often, then that means it has to have a total of 30 as the denominator of the probability. So for example, I'm going to solve this for 1. So this is the value of the roll, right? You roll a 1, and there's a 1/30th chance because it is an odd number. So that, of course, just equals 1 over 30. Now let's look at 2. Since it has twice the chance of 1, I'm going to put that as 2 over 30. So this is how you calculate expected value, is you're saying the actual value of the dice roll and then the probability of getting that dice roll. So the hard part with this problem is that, to me, I would do it manually, to be honest, because there definitely is a way that you could strategize a faster way to solve it, but I honestly think adding it all up is not too terrible. Ultimately, it's going to come out to 320 over 30. So what I would probably do is write out all of these probabilities, group the tens, and then ultimately end up with 320 over 30, which reduces down to 32 over 3 as our final answer. Square ABCD with side length 4 has E on the interior of CD so that CE equals 3. If AE intersects BC at F, what is DF? Answer in simplest radical form. The first thing I like to do is start drawing a picture. Knowing that this is a square and I'm going to be finding some sort of length and knowing that there's an intersection, I'm going to set it up on a makeshift grid. So kind of thinking about it instead on a X and Y axis. So square ABCD with side length 4. So we know that this is 1, 2, 3, 4. Has E on the interior of CD so that CE equals 3. So we already know the side length is from CD total is 4. So CE is going to be 3. So that means it's just going to be right there. As you can see, this problem extends a little bit beyond the square itself. So we're talking about the intersection of AE and BC. So BC is a straight line downward. Okay, so now given this, we can actually set it up using functions. So first, I'm going to set up the function for BC, which is this line. So this one's just a nice up and down straight line, which on the x-axis, it just rests right here at 4. So BC is x equals 4. Next, we want to try and find the equation for AE. The reason that I'm trying to find these equations is because then we can find where they intersect algebraically. So for AE, I'm going to be using a y equals mx plus b. So first we're going to be looking for slope, which is rise over run. So we already know that the side length is 4. So we already know the rise is 4. And then run means a change in x, which since we know that this from here to here is 3, and from here to here is 4, then we know this is 1. So slope, which is rise over run, would be the rise of 4 over the run of 1. So that would be 4. In this situation, it is negative 4 because the slant is going this direction. So that will be our slope. And then we're going to add the y-intercept, which we're already given the y-intercept, which is super nice. And that's right there at 4. Again, coming back to how it's a square, and the side length is always going to be 4. Okay, so now that we have this set up, we can actually really easily find the intersection because we are given the x value to plug into here. So then y equals negative 4 times 4 plus 4, which is equal to negative 16 plus 4, which is equal to negative 12. So now we actually know both coordinates of point F, because since it's on BC, we know that x is always going to be 4, and then we now know the y value is negative 12. Now let's come back to our question. So when it's saying what is df, it's asking what is the distance from the origin back to F right there, which if you'll notice, this actually just forms a triangle right here. Since we already know that this line, BC, is straight up and down, x equals 4, and that means it's perpendicular to the x-axis, then this is a 90-degree angle, and thus we can apply Pythagorean theorem. Okay, we can go ahead and assign variables. So our hypotenuse, of course, is going to be C, and then we'll call this leg A and this shorter leg B. So first A, we already actually know this value is right here, 12. We actually can ignore the negative number. Either way, it's going to be squared away, so it actually doesn't really matter. Okay, next our B value, which we've been given this from the very beginning, is going to be 4. So 4 squared is equal to C squared. 12 squared is 144, plus 4 squared is 16. So 144 plus 16 is 160. And then we're just going to square root both sides of that. We can factor it down to 16 times 10, which means we can pull out that square, which will be equal to 4 square root 10. And that is our final answer. All right, let's move on to question 17. Walmart sells 1 liter of lemonade that is 70% lemon juice and 30% water. Shriram pours 8 liters of this lemonade into a bucket that already contains 1 liter of water. He mixes the bucket, then pours X liters of the mixture back into the Walmart bottle so that it's full again. If the new lemonade is 50% water and 50% lemon juice, what is the value of X? Okay, so to get into this problem, I think starts with understanding how to work with concentrations and quantities. So the basic formula that we kind of need to keep in mind is that the quantity of, I think I'm going to focus on lemon juice for this problem, but you could choose to focus on water if you'd prefer, and both of them would help you solve for X, but I'm going to focus on lemon juice. So in order to solve for the quantity of lemon juice in whatever body of water as we're moving through this problem, we need to know that that quantity is equal to the concentration of lemon juice, which is the percentage, times the total amount of liquid. The way that I'm going to set up this equation, this is how kind of I thought about it, is a little bit working backwards. So if we're going to end, again, we're going to focus on lemon juice. We're going to end basically with 0.5 liters of lemon juice. So this is kind of coming back to this equation where the quantity, 0.5 liters of lemon juice, is the concentration of 50% times the total liquid, which at the end is 1 liter. So that means there's 0.5 total liters of lemon juice at the end of the problem. This lemon juice comes from 2 different places. First, the lemon juice comes from the initial leftover amount. Of the liquid still left in the bottle after Shriram pours some out, we know is 1 minus X, because there's 1 liter, and then X liters are poured out, which means there's 1 minus X. And then we're going to multiply that by the concentration of lemon juice, which is listed right up here to be 70%. Okay, so we know that quantity that was left over in the bottle. Next, we're going to figure out how much lemon juice came from this X liters, right? And we're all setting this up so that we can solve for the value of X. We know the amount of total liquid, right? We know that to be X. I've written out the second equation that, as you can see, is just a rendition of this equation up here, but now is focused on concentration. Because in order to set up this equation how I want to, I need to multiply X, because that's the total liquid, by the concentration of lemon juice in the bigger bucket, right? So then I need to actually plug it into this equation of quantity over total liquid. So the total quantity of lemon juice in the larger bucket, we actually already know what that is, at least in terms of X. Okay, then we're going to put that over right here, which is total liquid. And the total liquid in the bucket is the X liters added plus 1. So we know it's plus 1 because there's already 1 liter of water in there. And then from here is just algebra to figure it out. The first thing I did was first I distributed, and then as well I tried to put everything over X plus 1. This way everything was in the same area, and that's how we're going to begin to solve this. Alright, so first I'm going to multiply this out. So 0.7 times X, then plus 0.7 times 1, and then minus 0.7x times x minus 0.7x times 1. And then, of course, plus 0.7x squared, and then it's all over x plus 1. So, if you'll notice, there are things that can really easily cancel out. For example, we have this negative 0.7x squared, and then a positive version of that right there, and then the exact same thing there. So then this actually becomes a lot more simple. So we'll just multiply that x plus 1 over 1.5x plus 0.5 equals 0.7. Subtract, we have 0.5x equals 0.2. So then I'll just multiply this 2 over, and x equals 2/5. Just write that right up there. Okay, question 18. Integers x and y satisfy x squared plus 2x minus y squared equals 16. Find the sum of all possible values of x plus 1. So for this one, this requires doing something called completing the square, when you look at this right here, x squared plus 2x, that does remind me of a common factored equation that you'll see a lot. X plus 1 squared. So x plus 1 squared is x squared plus 2x plus 1, which is pretty close to this part of the equation. So we're going to do something called completing the square in order to give us something that we can kind of rearrange in context. So we're going to pull this down and instead do x plus 1 squared minus y squared equals 17. So the reason I'm making it 17 and not 16 is because of this extra 1 right here. We're adding an extra 1 to the left side, which means we must also do that on the right side, just by, basic rules of algebra. If this looks familiar, this is actually a moment of difference of squares, which I think is one of the algebra patterns that will come up all the time on competition math. If I pull this out, it's x plus 1 minus y times x plus 1 plus y is the same as that left side of the equation. Now that we have this factored, we can think about it like we would with any factored equation, right? Is that this part in these parentheses times this part has to equal 17. And we already know that that x and y are integers, so we don't even have to be thinking about fractions. So now 17, let's factor that. That's super straightforward. The only factors of 17 are 17 and 1. So that you know that the left side of the equation and the right side can only be positive or negative 17 and 1. And that allows us now to solve for all possible values of x plus y. Because of the negative on the left parenthesis, we can go ahead and ignore that part of the equation for now and just focus on this one, because now we know that this equals 17, or it could be negative 17, or it could be positive 1, or it could be negative 1. So now that we have that sorted out, we can actually solve within all of these what x plus y could be. So 16, negative 18, 0, and negative 2. So now that we have these four values, we can now sum all possible values. So that's 16 minus 18, that's negative 2, minus 2, it's negative 4. Now we're going to be going on to question 19. R, S, and T are the roots of the polynomial 3x cubed plus 15x squared minus 12x plus 6. What is the value of 1 over r plus 1 over s plus 1 over t? So this is a situation where you do kind of need to know some formulas in order to answer it. So in this situation, you need to be at least somewhat familiar with Vieta's formulas, because this isn't really something you can easily factor or deal with. So I think that really the only way to solve this problem is by knowing these formulas. So this is for cubics specifically, which this is, right? Because our highest degree is a 3. But basically you have your sum of roots taken 2 at a time, that's what it's called, equals c over a. And then product of roots r1, r2, r3 equals negative d over a. So we can get this all into one fraction with the denominator of rst, right? So, for example, if 1 over r suddenly had a denominator of rst, that would mean we multiplied by st on top. So we can continue that for the rest of these. So that's 1 over s, and then finally 1 over t, right? And that's what that would look like in the end, which is all equal to st plus rt plus sr over rst. And even though I'm using different formulas, that's actually perfectly applying to what we already have set up here, because this value right here, that's the same as multiplying the 3 roots, which is rst. And then these right here is the same as adding up the multiplication of roots 2 at a time, right? So now that we know these, we can actually just set up this same proportion right here. So we know that's C over A over negative D over A, which we can actually just use multiplication. And ultimately, this value is going to be negative C over D. So if you're asking what C and D are, these are how we typically refer to the coefficients within a polynomial. So usually it'd be A, B, C, and D. So we specifically need C and D, which are these two values at the end. So C equals negative 12, D equals 6. And so negative C over D is going to be negative 12 over 6, which ultimately just comes down to positive 2. Question 20. What's the units digit of 2026 to the 67th times 93 to the 2025th times 22 to the 41? Obviously, this looks really intimidating, but it's pretty easy to learn, especially when you realize that we're just focusing on the units digit, and units digits have patterns. That's the cool thing about multiplication as a whole. So, for example, let's take 2026. If we're focusing on the units digit alone, but the units digit is always going to end up being 6 times 6, which we know to be 36, which again always ends in a 6. So you can already know that with 2026, no matter how many times you multiply 2026 by itself, the units digit will always be 6. Now we can look at 93 to the 2025th. So again, we can ignore the 9 altogether because we're just focusing on the units digit. So first of all, we start with 3, then 3 times 3 is 9, then 9 times 3 is 27. So again, we just focus on the unit, drop everything else. 7 times 3 is 21, drop the tens, and we just have that. And then 1 times 3 will be 3, 3 times 3 will be 9, and it's just going to repeat the exact same pattern. So right there, we can realize that any time you multiply 93 repeatedly, it's always going to continue doing the exact same thing over and over again in this group of 4. And we're going to actually notice something really similar with 22 to the 41st. So we have 2 times, and then times 2 is 4, times 2 is 8, and then times 2 is going to end in a 6. And then when you multiply 6 by 2, you're going to end with a 2 in the unit again. So now that we realize these patterns, that 2026 is always going to end in a 6, and the rest of these will just repeat patterns, we can now just use basic long division to figure out which units digit this specific term is going to end in. And once we know what all 3 of them end in, we can just multiply those and again take the units digit. So with this 93 to the 2025th, we're actually going to divide 2025 by 4. So you'll notice here that there's a remainder of 1. In this value up here, 506, I actually don't need to know that value at all. The important value is the remainder of 1, because the remainder of 1 means that throughout 2025 powers of 93, we're going to go through this whole pattern of units digits 506 times. But then there's going to be a remainder of 1, and that's going to be when it lands on 3. So we know now that 93 to the 2025th is going to have a units digit of 3. Now we're going to do that exact same division over here on 22 to the 41st. Again, dividing it by 4 because this pattern is 4s. And it actually has the same thing where you're just going to have a remainder of 1. So this one is going to end in a 2. So 6 times 3 times 2, 6 times 6, it all ends back in a 6. So even though that looks complicated and you don't have a calculator to solve it with, you really don't need one, and you can do this by patterns alone. Now moving on to question 21. Haley and Tao each go to a coffee shop. They will each arrive at a random time between 1 p.m. and 4 p.m. Afterwards, they will remain there for 30 minutes. What is the probability they run into each other at the coffee shop? Express your answer as a common fraction. So this is a little bit of like a unique probability equation. So we wouldn't solve it as we normally would with casework, because casework would take forever since it's a 3-hour chunk and they can show up at literally any minute within that amount of time. So instead, we're going to have to get a little bit more creative. I think the first step would be to start thinking of this instead of probabilities, thinking of it more in a coordinate system. X is the number of minutes after 1 p.m. that Haley shows up to the coffee shop, and Y is the number of minutes after 1 p.m. Tao shows up to the coffee shop. In order for them to run into each other, the difference between those times that they arrive has to be less than or equal to 30. So that means they will meet. Because if the difference is less than 30, that means they'll run into each other because they're remaining there for 30 minutes. However, if their difference is greater than that, and I'm purposely doing absolute value bars here because the difference could be either direction. It doesn't have to be Haley shows up before Tao. It can be Tao shows up before Haley and they could still meet each other. So if this difference is greater than 30, then that means the first person will have left after 30 minutes and then the second person shows up. So that means they won't. Okay, so given these, now we can come back to this coordinate system and think about it using these equations. So first let's mark out the timing of this. So 1 p.m. to 4 p.m. is 3 hours, and then 3 times 60 is going to be 180 minutes. Okay, coming back to our equations for a moment, using this top equation that's saying when they will meet, we can derive two equations from that will actually help us figure out this area of time where they could be running into each other out of our entire area of 180 times 180. So we have x minus 30 is less than or equal to y, or x plus 30 is less than or equal to y. And the reason that works is because of the absolute value bars. So I've now colored in the model by plotting these two equations. So we can use them by, for example, this first equation, we know the x-intercept is going to be here at 30, so it'll just be right there. And then we know both of these slopes are going to be 1, which is why it creates two parallel lines. And then in the second equation, we know that when x equals 0 right here, then y is going to equal 30, so we know that's the starting point. And then knowing all of that, and knowing that they are parallel, it's going to be a distance of 30 from the top right there, which means this will stop at 150. And same with this one right here. Okay, so now that we have this model, we can now calculate the probability that they run into each other. So with calculating probability here, we know the total area is 180 times 180, so that's going to be our denominator. Then for our numerator, we're trying to calculate the area of just the yellow section minus these two triangles, because those two triangles represent the times which it's not possible for them to run into each other because they arrived more than 30 minutes from each other. So to find that, instead of finding the area of this center part, which might be kind of complicated, I'm instead going to take the area of the whole, which is 180 squared, which we already know, minus the area of these two triangles. So those two triangles can come together to form a square, because we know that this distance is 150, and this distance is 150. And so those could come together to form a square, so minus 150 squared. I think the first thing I would do here for simplifying this down, I'd probably just start by, of course, dividing by 10 all the way through, which I think simplifies this quite a bit. So 18 squared is 324, and then 15 squared is 225, and then that will be over 324. So now that we have that, we can simplify that down. So 324 minus 225, we can see that's just going to be 99 over 324. And then I just kind of worked with this until I found the common denominator being 9. And then that's going to come down to 11 over 36. And obviously that can't be reduced anymore. So your final probability is 11 over 36. Okay, let's move on to question 22. Chords A, B, and C, D are drawn on circle W such that they intersect at point X. Given that AX equals 6, BX equals 4, and CX equals 3, what is the length of DX? Okay, so we obviously don't know a ton of details about this, but I'm just going to draw one kind of for example. We know that they intersect at point X. So then AX is 6, bx is 4, and then cx is 3. So this is a situation where you would need to be able to know the intersecting chords theorem. Basically, it means that AB equals CD, that's the whole theorem, where A and B, kind of like as shown on here, are two separate parts of one chord, which actually really applies to this question, where basically that translates in this situation to AX times BX equals CX times DX. So now knowing this is actually pretty straightforward to answer because we're given these three values, which means we can pretty easily solve for the fourth. So AX is 6, BX is 4, CX is 3, and DX is what we're solving for, of course. So that simplifies it down to 24 equals 3 DX. So then DX is 8. Okay, let's move on to 23. What is the smallest positive integer that leaves a remainder of 1 when divided by 2, 3, 4, 5, and 6? So the real trick to this one is just being able to go through that language and understand that that's saying, what's the smallest positive integer that evenly divides 2, 3, 4, 5, and 6, and then that integer plus 1. So basically it's asking, what is the least common multiple of these 5 numbers plus 1? So there's a lot of different ways where you can find an LCM. What I did for this problem, just because I felt like I could kind of just logic it out, I started with multiples of 6 because that's the one that there's the least of. Basically, we're looking for a value that can be evenly divided by all of these numbers. So since we already know that all of these are divisible by 6, that means they're also divisible by 2 and 3, since those are the factors of 6. So basically, I'm just going to be going through it and checking which ones are not divisible by 4 and 5. For example, 6 is not divisible by 4, 18 is not divisible by 4, 36 is not divisible by 4, 32 is not, 54 is not, 66 is not. And then I'm going to be going through with 5s now. 12 is not, 24 is not, 36 is not, 48 is not, and then of course that only leaves 60. So now that we've gotten to 60, however you did that, which you might honestly just know off the top of your head, because that's a pretty simple one, we know that it's going to leave a remainder of 1, which means the answer is actually 61, because that's the one that when divided by all of these numbers, and then leave a remainder of 1. So that's how we know that's the right answer. Okay, let's move on to question 24. The cyclic quadrilateral ABCD has side lengths 4, 6, 10, and 12. What is the area of ABCD? Express your answer in simplest radical form. Okay, so this one actually comes down to first understanding what a cyclic quadrilateral means. This basically means that all 4 vertices of a quadrilateral are on the edges of a circle. So this obviously is not a regular quadrilateral like a square or a rectangle, so then that leaves us asking, how do we find the area of that? To solve this, you should know Brahmagupta's formula, which I've written out here. Brahmagupta's formula specifically applies to finding the area of a cyclic quadrilateral, so that it perfectly applies to this question, where A, B, C, D are the side lengths of this cyclic quadrilateral. So in this situation, S is called the semi-perimeter, and that's calculated by adding the sides and then dividing by 2. A plus B plus C plus D is 6 plus 4, that's 10, plus 10 is 20, plus 12 is 32 over 2, which is 16. Now we can plug this into the equation to solve for area. So we have 16 minus 4, 16 minus 6, 16 minus 10, and then 16 minus 12. Okay, so I've simplified it down to root 12 times 10 times 6 times 4. Since I have to put it in simplest radical form, I've broken these down so I can group them together. Right, so that's going to get us down to 6 squared times, we can put a 4 squared, and then times 5. So as you can see, we can pretty easily pull that 6 squared and that 4 squared out, and then 6 times 4 is 24. So that's 24 root 5. And that will be our final answer. Okay, find the real number x such that this equation is true. Express your answer as a common fraction. I started by assigning values to this first part of the equation and the second part, labeling those as a and b. So a is root x plus 2x minus 1. B is root x minus 2x minus 1. Now that we have these set, we can translate this to a plus b equals 3. And then we know we're going to actually want to get rid of those square roots we've just assigned to the values. So I'm going to go ahead and square both sides. So since we know the structure of a plus b squared, we can actually now apply that to make this a little bit easier to answer. So first we have a squared, which is just going to be this value squared. So that's going to be x plus 2x minus 1. And then let's go ahead and take care of the b squared as well, because that's pretty straightforward. It'll be the x minus 2x minus 1. And then we're going to figure out what 2ab is. So if we think about multiplying a and b, basically what we're doing is within a square root, we're doing this. This is pretty straightforward to solve, because if you think about solving something like x plus 1 times x minus 1, then we know that that would just result in x squared minus 1. So it's actually a very similar thing here, where, again, keeping it all within the square root is going to result in the x squared, and then just both of these multiplied together, since they'll cancel out in all other respects. So we'll multiply those two together, which is going to get us actually to negative 2x minus 1. Okay, so now that we have that, we can add that down here. So let's remember there's a 2 out front, and then square root x squared minus 2x plus 1. We can kind of simplify a few things. So I can already see that those two cancel, which is nice. So that just becomes 2x. And then plus 2 times this right here. This value of 2 root x squared minus 2x plus 1 is actually equal to 2, and then within the square root, x minus 1 squared. So if we simplify that down, that actually just comes out to 2 and then x minus 1. And then obviously that becomes pretty easy. That's just 4x minus 2. Technically, this should be in absolute value bars, which you could check, but actually for this problem, you don't have to. Okay, so now let's remind ourselves what the right side of the equation is, which is 3 squared, which is 9, of course. And then if we add the 2 to both sides, 4x equals 11. And our final answer is x is 11 over 4. Question 26. A giraffe is located at one vertex of a regular octagon. Every minute he randomly jumps to a neighboring vertex, each with equal probability. It's important. What is the expected number of minutes that pass before he returns to his initial vertex? So this one, I do think there are probably some creative ways you could solve it. There actually is a bit of a formula for this that's pretty easy to apply here, so I would recommend using that. On this area that's a regular octagon specifically, you have all these points that a giraffe is jumping between. And since there's 8 points and they each have equal probability, each of these points have a 1/8 chance. Okay, so this is the formula that makes this problem super straightforward. So on a random walk of a regular graph, like the regular octagon in this situation, the expected return time to a vertex is 1 over probability of the vertex. So in this situation, you really don't have to do any complicated math or anything like that. Really, you can just do 1 over 1/8, which is 8. So the expected number of minutes before he returns to the initial vertex is 8. I'm going to quickly skip down to 29, and then we'll keep talking about the remaining 3. Okay, Finn the frog is jumping around 5 lily pads in a circle, labeled 1 to 4 in a clockwise order. He is currently on the lily pad labeled 0. Each minute he jumps 1, 2, or 3 lily pads clockwise, each with equal probability. What is the probability that after 3 moves, he finishes on a lily pad labeled with an even number? Express your answer as a common fraction. So there's definitely a bunch of ways to solve this, but this one's actually pretty straightforward if you use a tree diagram. So we're going to start from our source, right, where he's starting at the lily pad labeled 0. he basically has three choices, right? From there. Is he could jump to lily pad 1, lily pad 2, or lily pad 3. Because if you recall, he can jump 1, 2, or 3 lily pads. So that's one move. Now, in his second move, each of those options that he chose before now has 3 more options. So the point of the tree diagram is basically a way of calculating cases where it's showing each possible route that he could take. So, for example, if he had only gone 1 lily pad, that would mean he's now at 1, which means he could go to 2, he could go to 3, or he could go to 4. If he's now on the second lily pad, he could jump to 3, 4, or back to 0. And then when he's on 3, he could jump to 4, 0, or 1. Okay, again, I'm going to do just the same reasoning, right? So if he is at lily pad 2, right here, then that's going to be 3, 4, 0. Or here, he's at 3, so that could be 4, 0, or 1. And then if he's at 4, it could be 0, 1, or 2. So now what I would do is I'm just going to go through and circle all of the even numbers. So I've now circled all of those, and there are 16 total. So for calculating this, we want how many times this specific event, which is getting a 2, 4, or 0, versus total routes, which is getting anything in the end. 8, 9, 10, 11. 16 plus 11 is 27. So that'll give us our total number of routes. So 16 over 27 is our final answer. So our last 3 questions, 27, 28, and 30, are highly complex and utilize really big math concepts that I don't think I have time to explain in this video, especially considering how long it already is. So props to you if you made it this far already. So if you do want to figure out what those last few concepts are, I've linked videos in the description that go in depth about what each of those concepts are and how you could apply them to a question like this. So those videos will give you a better sense of how to solve those than I think my brief solutions could. So do check in the description. They'll be labeled with the question as to what theorems or certain ideas you'll need to understand to solve them. But then otherwise, that about wraps up our review. So thank you so much for watching. I hope this helped you out a little bit. Hopefully this gave you at least something that you can apply to your next math competition or helps you better understand the test if you did take it. And we'll see you for spring comp. Bye.